So today's topic is process costing. Process costing has to do with getting a cost for a product which you can't separately identify when you produce it. Let's say, for example, you are making bread. You're able to count how many loaves of bread you've made, say maybe from a bag of flour. But if you're making cooking oil, you can't count how much cooking oil you've made because of the continuous nature of the product. That's where process costing comes in. So you want to determine this cooking oil, this juice we've made, this chemical we've produced, how much has gone into it. So you have to separate the total cost. You have to divide the total cost into the total output. The key to getting process costing questions correct is that the input should always be equal to the output. Whatever goes in is equal to what comes out, whether there is wastage or there is no wastage. It's all about formulas at the same time. You need to know the formulas. There are a number of them, but they're not complex. So we'll start with the first formula that we need to memorize, which is cost per unit equals input costs divided by units. So whatever input costs that you've incurred in a process, you divide by the units which have been produced. That will give you the cost per unit. We'll look at the first example where there are no losses, meaning whatever you've put in is equal to what comes out. You have a question in front of you. Input into process 1 during a period was 1,000 units of raw materials, which cost 40,000. Other costs were labor 50,000 and overheads 20,000. All of the output was transferred to process 1. So since there are no losses, the total number of units of 1,000 of raw materials which have been input should be the total number of good output coming out. So you produce that in your T account. When you add up the costs of labor, raw material and overheads, you get 110,000. Since the total units of raw material 1,000 is equal to the total units of the output 1,000, so the cost as well will be 110,000. So to get a cost per unit to be 110,000 divided by 1,000, that gives you the cost per unit of 110,000. Any question there? The next is where you have a normal loss. And the normal loss has got no scrap value. Now, what is normal loss? Normal loss is a loss which is expected. So what would be the cost per unit? The formula is cost per unit equals costs over normal output. So we continue with the same example we looked at earlier on. We now assume that there is a loss of 10%. 10% of 1,000 gives us 100. So if 100 is a loss, then the good output will be how much? 900. Now, since the normal loss has got no value, then the good output will still be valued at the total cost of what came in, which is 110. But now, since the normal output has reduced from 1,000 to 900, so the cost per unit also goes up to $122.22 per unit. Clear up to the point?
What example of product can have a normal loss?
What example can have a normal loss? If you are extracting oil from sunflower, the sunflower is a seed. When you crush and extract the oil, there's a cake which remains. That is expected because that's the nature of the sunflower. So that's a normal loss. So if you can't sell that one, then the whole cost of the sunflower should be allocated to the output, the oil. But some normal loss which is expected can also be sold. Because it's expected, it can be sold. That value is known as scrap value. An example would be what? If you killed a cow for the beef, you still sell the
offals and other part of the product usually.
No, the offals is part of the meat. But the skin of the cow, we don't eat that, do we? No, we don't. You still sell that for the people who make what? Leather shoes? But your aim was to get the beef. So the skin becomes scrap value, becomes normal loss with the scrap value. The formula gets modified to cost per unit equals input costs minus scrap value of normal loss over input units minus normal loss units. The normal loss, most of the times in the exams, you'll be given the value of the normal loss. But it can be calculated in different ways depending on the normal expectation of the process which is involved. You could use percentage of input, you could use percentage of throughput, or percentage of good output, or percentage of total output. We continue with the same example, but this time the normal loss, which we saw in the second example as being 10%, this time the 10% normal loss has got a scrap value of $20 each. You have your T account there. The input units still remain the same, 100,000. The total cost also remain 110,000. But this time the normal loss is valued at 20. So 100 units times 20 gives us a normal loss of 2,000. The good units, the value will be a balancing figure. Okay, you will have to calculate the value of the normal loss, but the good output, the value will be a balancing figure. So 110,000 minus 2,000 to give you 108,000. We apply it in the formula to give us a cost per unit of 120,000 per unit. We could also open a scrap account. So expect also to meet a question asking you what value you're going to have in the scrap account. At this level, they will not ask you to produce a T account, since the exam is computer based, but they may ask you, they may give you a question which already has T accounts, and then you identify which answer has got the correct double entry. We could also have an abnormal loss or an abnormal gain.
Before we move on to the next one, so for example, if the question is to give